This is the next section of that video series on Chapter 10. We're going to start talking about default route propagation. Of course, when we start talking about a default route propagation and we start talking about OSPF router roles, we're by definition talking about an ASBR. That's an autonomous system border router. You might also refer to it as the edge router, the border router, the gateway router, the entrance router. There's a lot of different terms for this. What we mean is the router at the edge of your OSPF area and the wider network. What we're going to do is create a default static route, a standard IPv4 quad 0 route, and then you go into the routing process and you do default information originate, just as you would on a RIP router. This is different from EIGRP in that the command we use here is not redistribute static, but default information originate. So we can verify that with show IP route. Show IP route pipe begin gateway or show IP route include gateway. You'll see the network of last resort is the next hop to the network quad 0. 000 is 000 is everybody. It'll also show up on the router that is producing that route as a static default route. On every other router in the domain, it'll look like an external route, O star EX or O star E2, depending on how it phrases the source of the origin code. You can also do the same thing in OSPF v3. Sorry about that. So, of course, in OSPF v3, the default route is IPv6 route ::/0. In IPv4, quad 0 is a network address that is all zeros and a mask that is all zeros. In IPv6, that : represents an IPv6 address that is entirely zeros. 128 hexadecimal bits worth, hexadecimal digits worth of 0. Then, of course, or actually, it would be. Never mind. It's not hexadecimal. 128 bits of 0, followed by a prefix length of 0, and following with that, of course, your next hop or your exit interface. And again, you use the default information originate command. You get into the routing process, you do default information originate, and boom. And of course, you can verify it the same way. Show IPv6 route static, and you'll see that static route at the bottom. If you do this anywhere else, you'll see an external route like OE1 or OE2 to indicate that it is a route that is coming from into the OSPF process from the outside. Let's also talk about hello and dead intervals. The hello and dead intervals, as we know, control the process of making neighbor relationships, or the how long those neighbor relationships last, how often it sends out hello packets. And this is important even when we're dealing, it's particularly important when we're dealing with multi-access networks, because the BDR is listening for hello packets from the DR. And if it loses the DR loses its neighbor relationship with the if the BDR loses its neighbor relationship with the DR, it will become the DR. Now, we can configure these on a per interface basis, but you probably shouldn't, honestly. What you should probably do is leave it all alone. And if you have a very good reason to tune a specific interface, change that. Say, for example, you have not just a slow, but a really slow serial line. Now, your slow serial lines are going to send their hello packets more often than usual, and they're going to wait longer than usual before they give up on the connection. But if you need it to be even longer than that, say you send a hello packet once every 5 minutes, that's probably excessive, because usually it'll send it once every minute instead of once every 10 seconds. So as you can see, from that 1 minute, every 10 seconds to 1 minute, that's still a significant backing off from the amount of data you're sending into the network just to establish neighbor relationship. To verify these, you can do show IP OSPF neighbor, and you'll see the address, the process ID, the router ID, the network type. It's a point-to-point link. It's a serial line. Okay. You'll see your transmit delay, your state, your timer intervals, your 10, your 40, and it's fine. Now, if you want to change that, make that 15 and 60 or whatnot, you can do that. Just remember, if you change that on one side of the link, you have to change it for everything in the link. So if you've got a couple of serial lines, they have to have the same hello and dead intervals. If you're talking about multi-access network, everybody has to have the same hello and dead intervals. So, but we can, like I said, we can modify this if we need to by going into the interface and do IP. You can do, okay, let me move myself. Okay, now that's better. You can go into the interface mode, do IP OSPF hello interval and the number. IP OSPF interval and the number. Now, if you're going to do this, it might not be a bad idea to bring the interfaces down, change it, bring them back up again. Because if you do this, and you don't do the other side fast enough, it'll break that neighbor relationship, which you probably don't want, which is what we see right here. If you set the one side, if the one side has a default values of 10 and 40, and this one has default values of now has values of 5 and 20, it's going to be sending hello packets every 5 seconds. And it's not going to wait for 4 hello packets to go by. Actually, it is waiting for 4 hello packets to go by, but the other guy's still sending them once every 10 seconds. So he sent 2 hello packets while this guy is waiting, is expecting to have gotten 4. The neighbor relationship falls apart. Now, if you want to change that, if you decide, you know what, this was a bad idea, go back into the interface, do no IP OSPF hello interval, or no IP OSPF dead interval. Now, this is one of those commands where you don't have to specify the thing you're trying to take out. It's like an IP address in IPv4. You don't have to tell it which one you're taking out. You just do no IP address and it's gone. As opposed to, and this is even true on IPv6 interfaces, whereas with an IPv6 address, if you want to take the address off, you have to specify it completely. Because, of course, an interface can have more than one IPv6 address of any given type. With this, all you do is no IP OSPF hello interval, and it will reset it. Just like setting bandwidth or resetting bandwidth. If you set the bandwidth command with, say, bandwidth 64, to tell it to treat itself like a 64 kilobit line. If you want to change your mind about that, you go in and do no bandwidth. It's gone. So, like I said, works the same way in v6. That's great. Next, we'll talk about troubleshooting single area OSPF implementations. Thanks.